Good morning, everyone. We're going to be working on solving one-step equation using inverse operation. Right. So what's inverse? So it's the opposite operation of, let's say, if you have addition, you had to do the opposite of that to redo or undo the equation. So let's see some examples to understand what it means. So let's say, for example, we have addition equation here, x plus 4 equals 9. So if we're going to be working on isolating the variable x, so we're going to do the reverse or inverse of the operation to undo the equation. So we have x plus 4 equals 9. So we'll do the inverse of that. So that will be minus 4 or negative 4 on both sides of equation. Remember, it should always be both sides of equation to satisfy that statement that it tells there, equal. So you did it here, you did it here, so you do it equally. So that will be fair. So then combine terms or add. So that will be x to nothing. So you're just going to have x. Then obviously that's 4 minus 4 is a 0. You don't have to write down. And then we have 9 minus 4 that gives you 5. And if you want to check if your answer is correct, so we're just going to go back to the original equation, which is x plus 4 equals 9, right? So if you're going to do that, x is going to be 5, right? Plus 4. It says here plus 4 equals 9. And obviously, we see that it's 9 equals 9. Well, that said, that 5, our answer is correct. So when you go back check, you always have to go back to your original 5. Let's see in the second example. We have x plus 7 equals negative 10. You could also say that's minus 10. They function the same way. So doing the inverse, we're going to do negative 7 or minus 7 on both sides of the equation to satisfy that statement, which is equal. Then we combine terms, that's x. And then 7 minus 7, obviously is 0. And then we have here 10, negative 10 and negative 7 together. You are combining them. And if you see that's negative and negative, when you add two negatives or combine two negatives, you're just going to copy the sign. And you have to add the terms or the numbers. 10 and 7 gives you 17. Alright, so if you look over here, if we go back, that's positive 4 and minus 4. The signs are not the same. And if we want to check if x equals 17 is correct, we always just have to go back. So that's going to be, you could say, give me a second. So that's negative 17, okay, plus 7 equals negative 10. So we know that using adding integers, we have negative 17 plus 7, that's negative 10. According to the rules in adding integers, it's negative 10. So with that said, we know that x equals 17. Negative 17 is correct. Next one. This is almost the same with the first one, but this is just a subtraction equation. So we're still going to be using inverse operation, and still the same rule applies. So we do the inverse. So that's x minus 3 equals 8. So obviously, the opposite of minus is plus. So you put plus 3 on both sides of the equation. Okay. So this is going to be x. 3 minus 3, and or a negative and a positive, you subtract them when you combine them, and it's 3 and 3, so it's 0. And then you put equal sign here, and 8 plus 3 gives you 11. If you want to check if you got that right, so we'll see, we'll go back to the original problem, x minus 3. So we know that x is 11 at this point, minus 3 equals 8. Okay, so now 11 minus 3 is 8. That gives you equivalent to 8. So now we know that 11 is the correct answer because 8 equals to 8 when we check is correct. Next one. So that's x minus 2. We know that it is with the opposite or inverse is plus 2 or positive 2, and you have to do it on both sides at all times to make that equal sign true or the statement correct at all times. So that's 0, and that gonna be, if you look over here, that is negative and that's positive. When you combine terms like that and they are not the same sign, we subtract them. We'll look at the number 5 and 2, so that's 3, because we're gonna subtract them, right? But then what will we know which sign we're gonna use? So we're gonna get the absolute value of this. So if you're gonna get the absolute value of the negative 5, I'm sorry, erase that. So that was negative 5. If you get the absolute value of negative 5 and absolute value of positive 2, we're gonna get the higher absolute value is 5. So we're gonna get the sign of 5. So that's gonna be negative 3 as the answer, because we're taking the sign of negative 5 that has the higher absolute value. And if you want to check it, okay, so we're gonna go back to negative 3. Let's see if we got that correct. Negative 3 minus 2, is it really negative 5? So we know, again, we combine terms. This is the same term. So negative 3 and negative 2 is negative 5. If we combine them or we add them, is equivalent to negative 5. And that will prove that x equals to negative 3 is correct. Let's go to the next one. All right, in this case, we're gonna do a multiplication equation. So if you look at this, 2x equals 16. 2x means 2 times x. So if you're gonna isolate the x by using inverse operation, so we're gonna divide 2x by 2 to make it only 1, right? Because 2 divided by 2 is 1. Since we do that here, we're gonna have to do it on the other side of the equation. Then 2 divided by 2 is 1x, or you could just say x. You don't need to really write 1 over here. And then 16 divided by 2 is 8. And if you want to check if our answer is correct, you always just have to go back to the original problem, right? So if you're going to go back to the original, that will be 2, and that's the x. And we know that x here is 8, so we're going to multiply that to 8. That gives you 16. So just double checking, 2 times 8 is 16. And that is definitely equals to 16. So I could prove now that x equals to 8 is correct. Let's go to the other side. So that's negative 7x or minus 7x, or negative 7 times x equals 21. So since I said times, the opposite of times is divide. So we're gonna divide this with negative 7, because if I'm gonna just divide this with 7, the answer gonna be negative x, and that's not what we're looking for. We're looking for the value of x. So we carry the sign. So negative and negative, we know that it's positive. So that also will go here. Okay, so now negative and negative is positive. So 7 divided by 7, negative 7 divided by negative 7 is 1. So they're gonna be x equals, since that's positive and that's negative, we know the rule in integers: when you divide or multiply sign numbers with different signs, it will be negative. So negative divided by positive, or positive divided by negative, you're going to get a negative answer. 27 divided by 7 gives you 3. So let's see if we check if we got it correct. We always have to go back to the original problem. So that's negative 7, and we know the x this time. See, we're going back here, correct? So the x this time is negative 3. And then it says that it's 21. Alright, I'm squeezing it on the side. So negative and negative is positive. 7 times 3 is 21. So we know that that's 21 equals to 21. And with that said, I know right away that my answer, that's x equals -3, is correct, because based on my checking, both sides of equation satisfies them. Set of equations we have is division equation, right? So, but it was written in fraction. You guys, as soon as you see a fraction, you're in a panic mode. My student this morning said, "What is that? How is it done?" So I usually rewrite them in a way that we understand it. So 3/4 x is actually it's 3x over 4. How did it happen? So we know that the variable, the x over here has a denominator of 1. So we could multiply 3 times x, 1 times 4, that gives us 3x over 4. And we also know that 5 could be written as 5 over 1. We are all expert in doing ratios, cross multiply. So we just do that. So we're going to do 3x times 1. That gives you 3x. And then we could also cross multiply 4 times 5. That gives us 20. In this case, it just happened that it is 3 times x again times 20. So the next step we're going to do is divide this by 3 and divide this by 3. So we simplify that. So we also know that 3 divided by 3 is 1, so we have 1x left. Then 20 divided by 3, we give like, we do mental math. So how many 3 I get from 20? So we get 6. So we know that 6 times 3 is 18, so we have a remainder of 2. So we're going to have 6 and 2/3. Unlike the way we did before in the previous examples, we could always go back to multiply and check if x is done. So if x is 20 over 3, we could say 20 times 3 is 60, and then 4 times 3 is 12, so 60 divided by 12 is 5. So we know that our answer is correct. Again, here, I usually like to rewrite them. It is in this way. It looks this way. That it looks like funky fraction. But we could always do it like multiply both sides by 2/5. But I'd rather do it in a simple way. So I rewrite this into 2x over 5. As I said, you could always multiply both sides by its reciprocal. You could multiply this by 5 over 2 to make it 1. And you could also multiply this by 5 over 2. You could also do that. There are different ways of solving an equation, but I love inverse operation most, right? So, and this I could write as -4 over 1. And then we could cross multiply. 2x times 1 is 2x. And then I could cross multiply -4 and 5 to get -20. And we know in the previous example that we could divide both sides by 2, since this is isolating x out of 2. So divide it by 2, and we divide this by 2. So that x therefore is negative and positive is -20 divided by 2 is 10. I don't have space to do the check, but let's do mental check. So x equals -10, do mental math for that. So 2 times -10 is -20 divided by 5 is -4. So now I know that x equals to 10 is correct. So if you have more questions, you could always go back and see other videos that I have. You could always review the lessons that I have. You could always go back. Alright, thanks for now, guys, and wish you luck in solving one-step equation. Have a good day and happy springtime. Bye for now. Until next time.